Okay, so we're going to move on to RL circuits. We've already seen RC circuits, and we're going to see that a lot of what we've learned we applied directly in RL circuits. So we're going to look at it again in the separate parts. Again, I encourage you to look at the ET111 videos that I've created that covers this topic almost identically, and in some cases more in depth. So we're going to look at series, parallel, and the series parallel relationships. Look at again what happens in lead lag, the phase differences, and then look at something called inductive susceptance. So as with RC circuits, all currents and voltages in a series RL circuit are sinusoidal when the input voltage is sinusoidal. So whatever you see at the source, generally we are going to treat it as a sinusoidal source. The inductance causes a phase shift between the voltage and the current that depends on the relative values of the resistance and the inductive reactance. Again, exactly what we saw with the RC circuits. Okay, so just like we saw with the RC circuit, now we've replaced the capacitor with an inductor here. And we can see the little traces of the sinusoid of what's happening here as the signal propagates through the circuit. The resistor voltage V sub R, the inductor voltage V sub L, and the current are all sine waves with the frequency of the source. And generally, again, that frequency will be given to you because you will need it to solve for the reactance. Phase shifts are introduced because of the inductance, the illustration then of the sinusoidal response with general phase relationships V sub R, V sub L, and I current are relative to the source voltage. V sub R lags V sub S, V sub L leads V sub S, and I, the current, lags V sub S. V sub R and I are in phase while V sub R and V sub L are 90 degrees out of phase. The resistor voltage V sub R and the current lag the source voltage. Okay, so we can see that here. Resistor voltage V sub R, the blue trace, and the current, the blue trace here, shows that we have a lagging. The inductor voltage V sub L leads the source, so now the blue trace here for the inductor V sub L, you can see, is leading the source voltage. And again, the note on the bottom of the page covers all of the responses. The amplitudes and the phase relationships of the voltages and current depend on the value of the resistance and the inductive reactance. So you will see the amplitudes vary as you do your calculations and or make your measurements using your oscilloscope. When a circuit is purely resistive, the phase angle between the source, applied voltage, and the total current is zero. So there's no phase angle with just a resistor, and we've seen that. When a circuit, though, is purely inductive, the phase angle between the applied source and the voltage and the total current is 90 degrees out of phase. So we can see that both in the sinusoidal representation and the phasor representation. Notice now we have I sub L going in the negative direction or making an angle of minus 90 degrees. When there is a combination of both resistance and inductive reactance in a circuit, the phase angle between the applied voltage and the total voltage is somewhere between 0 and 90 degrees, depending again on the relative values of the resistor and the inductive reactance. Okay, so we're going to look at then developing this impedance and phase relationship. The impedance of a series RL circuit consists of resistance and inductive reactance. Remember, just like we saw before, the resistance and the inductive reactance are measured in units of ohms. The total opposition then to a sinusoidal current, then the unit being ohms. The impedance also results in a phase difference between the total current and the source voltage. Therefore, the impedance consists of a magnitude component and a phase angle. We're still dealing with vectors, we call them phasors. The component then is represented as the phasor quantity. So when we come back, we're going to develop this relationship then of the impedance in an RL circuit and look at the phase difference, the phase calculation, and or the magnitude.